Right here, I'm Oyo. You can call me Oyo. I'm a chemist taking bachelor's degree in chemistry. So today I'm going to take you through the Jablonski diagram. This is under photochemistry. This is a simple pictorial representation or a sketch of Jablonski diagram. So you can see here. You can just see here. So this on the y-axis we have the energy, and here this is 0. This is the ground state. So the ground state of the molecules, of where we find the electrons. Then this is the excited state. So this is S2, the singlet state in different states. So we've got to each vibrational level. So we've got this one, that is spin up and spin down. So in singlet ground state, this is singlet ground state. So here in singlet ground state we have what we call the spin multiplicity. Spin multiplicity. So spin multiplicity, we have got this simple formula of getting it, 2s plus 1. And what is this s? This s, the s right here, s, it is the total spin angular momentum. Total spin angular momentum. Spin up. In spin up, S is positive half, and spin down S is negative a half. So in spin up here this is positive a half, this is negative a. Singlet excited state, you find that after the electron has spin up, it will reach a certain level, it will come to relaxation. That's where we have the spin down in different vibrational levels. So this is singlet excited state. And of course we have 3 states, that's singlet and triplet. So in triplet excited state, here both multiplicity undergo spin up. So this is positive a half, this is triplet excited state, is a parallel spin, while this singlet excited state, it is an anti-parallel. I don't know what you call it, but anti-parallel spin. Example, this of an spin multiplicity, which is given by 2s plus 1. So we can find for the singlet ground state, so by the formula 2s, taking the s here for the singlet ground state, so it will be 2 into s, which is positive a half, then minus a half, here this one, minus a half plus 1. Do that math. 1. So for triplet excited state, it will be 2s plus 1 is equals to 2 bracket a half. So here this one, it will be this plus this. They are both positive, so half plus a half plus that one 3. So this is the simplicity of the triplet excited state, and this is for singlet excited state. All electrons in the ground state here, all the electrons in the ground state will hit here at S0. Heating take place. The molecules with presence of UV light, ultraviolet light, so the electron moves from the ground state to excited state, that is to any vibrational level of the excited state. So what we mean is that the electrons move from the ground state here, S0, to the excited state, S2. It comes from S0 to S1, S0 to S2, to any vibrational level. What we mean by vibration levels, so these are the vibrational levels. These are the vibrational levels. These lines are the vibrational levels. Okay, but when the electron is to the higher state, we all know it's unstable, so it tries to come back to the lower energy state. So it loses energy. So when it loses energy, it tries to stabilize itself to the ground state. And when it loses energy, it can undergo two types of processes. It can emit light. It can undergo phenomena such as fluorescence and phosphorescence, or lose energy by losing some heat. See that within the same singlet state, or triplet state, electron from the higher vibrational level come back to a lower vibrational level just by losing heat. We call it vibrational relaxation. So this is what we call vibrational relaxation. Here the electrons move from here vibrational level to this vibrational level. So the movement, this is what we call vibrational relaxation, and it is assigned by the a wavy line. Vibrational relaxation. Electron can move from S2 to S1, a process known as internal conversion, which is the same state. It can move from here, from S2 to S1. This movement, it's called internal conversion, and here it's after the absorption takes place in the singlet state. Also, electron can move from S1 to T1, that is from singlet state to the triplet state, a process known as intersystem crossing, which is different states, that is singlet to triplet state. As we have said, when it moves from the singlet state to triplet state, from S1 to S0 to the ground state, excited state to the ground state, by emitting light. That phenomena is known as fluorescence. The emission of light, where the electron tries to stabilize itself from the singlet excited state back to the ground state, and it comes back to the ground state to the different vibrational level of the ground state. That's fluorescence. And when the electrons comes to the lower vibrational level of T1, this is the triplet state.
to the triplet state, it goes to the ground state, direct 0. It emits light, a phenomenon known as phosphorescence, which takes 10 to 10 power negative of 6 seconds. This takes less time. This process from movement of the transition of the electrons from the triplet state to the ground state, it takes lesser time, because electron comes from the singlet to triplet, then triplet to ground state. All these are known as photophysical processes.